Right, 9.1. In 9.1, we're going to talk about these 6 trig functions that go along with triangles. So our 6 trig functions are sine, cosine, tangent, cosecant, secant, and cotangent, which we'll talk about them a little bit more on the next page. But we're going to be given a triangle, and we're going to have an angle. Usually the angle will be given, so that angle will be theta. That's the angle that we're talking about. Theta. Theta. This symbol is theta. Now, if theta is the angle over here on the left side of our triangle, the side opposite, so the side that does not touch theta at all, is called our opposite side. The side that's next to it is our adjacent side. And then the side that's opposite of the right angle, so think about that right angle that points in the direction this way. That would be our hypotenuse. So the hypotenuse is opposite of the right angle. So it's important to tell which side is which. You have the opposite, adjacent, and hypotenuse. So each trig function relates to different sides of the triangle. So sine of theta is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. Tangent is equal to opposite over adjacent. So these are our 3 main trig functions. We'll talk about the other 3 in a second. But one way to remember those 3, which opposite, adjacent, and hypotenuse go with those 3, is SOHCAHTOA. Anybody remember this from geometry? Well, it's coming back. So sine stands for opposite over hypotenuse. Cosine stands for adjacent over hypotenuse. And tangent stands for opposite over adjacent. So if you know SOHCAHTOA, you know your sine, cosine, and tangent. Now the other 3 trig functions are called reciprocal functions. They're the same as the one that's right above. So cosecant goes with sine, but it's the reciprocal. It's the flip of it. So instead of it being opposite over hypotenuse, it's now hypotenuse over opposite. So you just need to know that cosecant goes with sine. Cosine goes with secant. So instead of cosine being adjacent over hypotenuse, secant is hypotenuse over adjacent. And then cotangent goes with tangent. So you just have to know the pairs, which one goes with which. So these 2 go together, these 2 go together, these 2 go together. All right, so example 1 says evaluate the 6 trig functions of angle theta. So we're going to start with our first 3 main functions, main trig functions. So we have sine, cosine, and tangent. I'm also going to write SOHCAHTOA up at the top to help us with our 3 main trig functions. Now, before we can evaluate, we need to know what our opposite, adjacent, and hypotenuse are. So looking at our triangle, we have theta up here. So would 12 be opposite, adjacent, or hypotenuse? Opposite. Awesome. It is opposite of theta. What about 5? What would that be? Adjacent. It's right next to theta, and it's not the hypotenuse, so that would be adjacent. And then our hypotenuse, we don't know what that is. We're not sure yet. There's a little formula that we can use to find it. What is it? You're close, yeah. Awesome. A squared plus B squared equals C squared. What is this formula called? Pythagorean theorem. So we use the Pythagorean theorem to find the missing side. So c squared, c has to be the hypotenuse. It's always the longest one. That's your hypotenuse. The a and b doesn't matter which one's which. You can say 5 is your a or 5 is your b. Doesn't matter as long as you're adding just the two legs together and it's equal to the hypotenuse squared. So we can say 5 squared plus 12 squared is equal to c squared. So 25 plus 144 is equal to c squared. This would be 169 is equal to c squared. Now how would I find what just c is? Square root both sides. What's the square root of 169? 13. Awesome. Bless you. Bless you. So c is 13, which means our hypotenuse is 13. So for these types of questions, it'll give you two of the sides. You have to use your Pythagorean theorem to find the third. Everybody good with this? All right, so let's find our trig functions now. So sine, according to so, is what over what? Opposite over hypotenuse. So what's our opposite? 12, and what's our hypotenuse? 13. So 12 over 13. Cosine is what over what? Adjacent over hypotenuse. So what's our adjacent? 5. And what's our hypotenuse? 13. Perfect. So 5 over 13. And tangent is what over what? Opposite over adjacent. Opposite is 12 and adjacent is 5. Awesome. So these are our three main trig functions. Now we can find the other three by just flipping these. So it's important to know that sine goes with which trig function? Cosecant. So cosecant theta would be the reciprocal of sine. So it would be hypotenuse over opposite. So we just flip it. So what would it be? 13 over 12. Perfect. Cosine is the reciprocal of which trig function? Secant. So that would be hypotenuse over adjacent, which would be what? 13 over 5. And then tangent is the reciprocal of which one? Cotangent. Which would be adjacent over opposite, which is what? 5 over 12. So the flip of that answer. So instead of 12 over 5, you flip it to be 5 over 12. Yes.
So on a test, would you make this find like cotangent, or would you tell us tan?
A test may ask for all 6. The homework asks for all 6. If this question was on the test and it only asked for one, let's say if it asked for secant, I would definitely find cosine first and then just flip it. So it's easiest just to find the one that it goes with and then flip that one. So let's do number 1. So on top, just as a refresher, I'm going to write SOHCAHTOA. So I need to find sine, cosine, and tangent. But before I find any of my trig functions, what do I need to do? Find what c is. I need to find my hypotenuse. So we know that this is our hypotenuse. Let's do Pythagorean theorem to find that. So we have 4 squared plus 3 squared equals c squared. 16 plus 9 equals c squared. 25 equals c squared. So what does c equal? 5. Awesome. So our hypotenuse is 5. So theta is down here at the bottom now. So 3 would be what? Opposite. and 4 is adjacent. I think it's super helpful to label which one's which. That way when you plug them all in, it's easy. You just have to look at your labels. A lot of people will make a mistake when plugging it in just because they flip a number around. So I think it's just easiest to label it right off the bat which number is which. So sine is what over what? O over h. Opposite over hypotenuse. So what would that be? 3 over 5. Perfect. Cosine is what over what? A over h. So what would that be? 4 over 5. And then tangent is what over what? Opposite over adjacent. So what would that be? 3 over 4. So those are our 3 main trig functions. Which trig function is the reciprocal of sine? Cosecant, CSC. So cosecant of theta would be what? H over O, which is 5 over 3. Which trig function goes with cosine? SEC, secant. So it's secant of theta be 5 over 4. Awesome, we just flip cosine. And then lastly, cotangent goes with tangent. And that would be 4 over 3. Perfect. So these are our 6 trig functions. What should we do first for number 3? We can label everything. So our theta's up top here. So what would be opposite? The one on the bottom, the missing one. This is opposite. So we'll figure what that one is in a second. What would 5 be? Adjacent. And then what is 5 square root 2? Hypotenuse. So how can I find my missing side? A squared plus B squared equals C squared. Oh, well, yeah, I guess. Well, let's just stick with A squared plus B squared equals C squared. But what's our missing one here? B. Because this is our hypotenuse, so this has to be C. Hypotenuse is always your C. So we can leave it as A squared plus 5 squared is equal to 5 square root 2 squared. So A squared plus 25 is equal to, here we have to be careful because it's the 5 that's being squared and the square root 2 that's squared. So 5 squared is 25. What's square root 2 squared? 2. So 25 times 2? 50. Then we subtract 25 from both sides to get that A squared all by itself. So A squared equals 25. So what is A? 5. Take the square root, so we get 5. So our opposite is 5. Drop. All right, so let's find our trig functions. So let's start with sine, cosine, and tangent. So sine is what over what? Opposite over hypotenuse, so that would be 5 over 5 square root 2. Can this simplify? How? The 5's cancel. Since I'm multiplying the bottom by 5, you can just cross them up. So this is 1 over square root 2. Now we learned this way back in, I think, chapter 4. We can't leave a square root on the bottom of our fraction. So what do we have to do? Awesome. We have to rationalize, so we multiply the top and the bottom by square root 2. So we get square root 2 on top. And what's square root 2 times square root 2? 2. So sine of theta is square root 2 over 2. So anytime you have a square root on the bottom, you have to rationalize. So cosine would be what over what? Same thing as sine. So it'd be 5 over 5 square root 2. Because this would be adjacent over hypotenuse. The 5's cancel. So I get 1 over square root 2. And when we rationalize, what do we get? Same thing. Square root 2 over 2. And then let's find tangent. Tangent is what over what? Opposite over adjacent, so 5 over 5. And what does 5 over 5 simplify to? 1. So here are 3 main trig functions. Let's find our reciprocal ones. So sine goes with which trig function? CSC. So cosecant theta. Cosecant theta is what over what? Hypotenuse over opposite. So it'd be 5 square root 2 over 5. Can we simplify this? How does it simplify? Square root 2. Any questions on that one? Let's find secant next. So secant is hypotenuse over adjacent. So 5 square root 2 over 5. Same thing. 5's cancel, so we're just left with square root 2. And lastly, let's find cotangent. Cotangent is adjacent over opposite. So 5 over 5, which is 1. So there are our 6 trig functions. All right, example 2. In a right triangle, theta is an acute angle and sine is equal to 4 over 7. It says evaluate the other 5 trig functions. So it gives us sine. If it helps, draw your triangle and put theta on your triangle. Sine is what over what? Well, let's write our SOHCAHTOA. Awesome. Opposite over hypotenuse. So that would mean 4 is opposite and 7 is hypotenuse. So you just have to use what you're given. That'll give you 2 of the sides. So opposite of theta is 4. The hypotenuse is 7. So which one's missing? The adjacent. How do I find the adjacent? Pythagorean theorem. A squared plus b squared equals c squared. Your hypotenuse always has to be the c. The a and the b don't matter which one's which. So we could say 4 squared plus b squared is equal to 7 squared. So just make sure your hypotenuse is your c. It's going in the c spot. C always has to be the hypotenuse. So 16 plus b squared equals 49. What would I do next? Subtract 16. So b squared is equal to 33. So what is just b? Square root of 33. Let's see if we can simplify. What are 2 factors of 33? 11 and 3. Can I break down 11 anymore? Can I break down 3 anymore? Do I have any pairs? No. So just square root 33. Okay. So we need to find our other 5 trig functions now. It gave us sine, so we can skip sine. We need to figure out cosine of theta, tangent of theta. Which one goes with sine? Cosecant theta. Which one goes with cosine? Secant theta. And which one goes with tangent? Cotangent theta. Yes. Yes. So first, let's find cosecant. Since we already have sine, what was sine of theta? 4/7. So what's the reciprocal of that? 7/4. Perfect. Next, let's find cosine. Cosine of theta is what over what? Adjacent over hypotenuse. So what would that be? Over? Awesome. Square root 33/7. Do I have to rationalize that one? Nope, because the square root's on top. Perfect. So what would secant be? 7 over square root 33. We just flip it. Do I have to rationalize this one? Yes. How would I rationalize? Multiply square root 33 on the top and on the bottom. So 7 square root 33 over 33. Can I simplify the 7 and 33? No. 7 doesn't go into 33, so we're good there. Okay, and lastly, let's find tangent. Tangent's what over what? Opposite over adjacent. So that would be 4 over square root 33. Do I have to rationalize this one? Yes. We multiply the top and the bottom by square root 33. So what does that give us? 4 square root 33 over 33. Perfect. And what would cotangent of theta be? Awesome. We can take the unrationalized one, the one that we started with, and just flip that. So it'd be square root 33 over 4. So these would be our remaining 5 trig functions. All right, number 4. In a right triangle, theta is an acute angle, and cosine of theta is equal to 7/10. Evaluate the other 5 trig functions. So I'm going to start with SOHCAHTOA. Cosine would be what over what? Cosine. Adjacent over hypotenuse. So 7 is our adjacent and 10 is our hypotenuse. If it helps, draw your triangle. Just draw a right triangle. Put theta on there and your right angle. Adjacent would be 7. Hypotenuse is 10. What are we missing? The opposite.
Wait, can you put your theta anywhere?
You can put your theta anywhere. One of the acute angles, it could either go down here or here. If you wanted to, if your right triangle goes this way, that's fine too. You can put your theta here. How would I find the opposite? A squared plus b squared equals c squared. What's my a squared?
7.
So 7 squared. What's b squared? Just b squared. We don't know what that is yet. And what's c squared? 10 squared. What did you get for b squared? Square root 51. Perfect. So our opposite is square root 51. Can that be simplified? Did we try? Okay, good. So let's find our 5 remaining trig functions. We have sine of theta. Cosine was already given, so then we can just skip to tangent. 51. And then which one goes with sine? Cosecant theta. secant goes with cosine, and cotangent goes with tangent. So sine would be what? Square root 51 over 10. Awesome. So cosecant would be what? 10 over square root 51, but what do we have to do to that? We have to rationalize. So multiply the top and the bottom by square root 51. So 10 square root 51 over 51. What would secant be? Awesome. We just flip cosine, so that would be 10 over 7. What's tangent? Perfect. Opposite over adjacent, so square root 51 over 7. And cotangent would be? Awesome. We already rationalized it, so square root 51 over 51. Did anybody get all 5 right? Perfect. You guys are geniuses. This is where we're going to stop today.